In this video, I'm going to solve some questions from the chapter Relation and Functions, starting with MCQs. In the first question, we are given an ordered pair. We are given a set, say set A is given. We are given a set A and a relation which is defined with an ordered pair that is 1, 2 as one of its element. Now, what we can see that among the options given here, clearly it is not reflexive. Reason being, we do not have a doublets like doublets of all the elements present in A. Like we do not have, since 1, 1 does not belongs to R, that should be sufficient to say. Otherwise also 2, 2, 3, 3 are not there. So it is not reflexive. It's not symmetric because we have 1, 2 that belongs to the set R, but you can see that there is no 2, 1. 2, 1 does not belongs to R, so it is not symmetric. It can be called as transitive because we know that whenever AB belongs to R, but there is no element, there is no ordered pair starting with B, that means BC does not belongs to R. So we say that it is transitive by special case. In the next question, there is let R be a relation here from a set of n, that is natural number given by R ABs, such that A is equal to B minus 2, well, B is greater than 6. Then which of these ordered pair belongs to this relation? Let's check for the first one. Clearly here B, which is 4, and it is not greater than 6. So this cannot be one of the ordered pair. B here is 8, which is more than 6. Now check A. A has to be B minus 2. That means A, which is 3 here, must be equal to B minus 2. B is 8. 8 minus 2. So A should be what? A should be 6 here, but A is 3. So this is again not the correct answer. Now coming to the next here, B, the first condition that it should be greater than 6, which is true. Now A, which is B minus 2, that is 8 minus 2. So A should be 6, which is correct. So we'll say that the correct option in this case is C. In question number 3, we are given a set of natural numbers starting from 2 and ending at 18. And this is the symbol for the relation here to be equivalence relation from A cross A defined by this. And the definition of the relation is AD is equal to BC. We are supposed to find the number of ordered pair of the equivalence class this. So what does it mean that, let's say, we are given AB, R, CD, and such that A into D, that is first into last, the product of the extreme is equal to product of these two mean, that is BC. Now we have to find out all other ordered pair which belongs to this equivalence class. That means, let's say if I consider X A as 3 and B as 2, it implies that A into replacing A here with 3, D replacing B with 2, C. So I can rewrite this as D over C is equal to, or C over D, that's all same. So if I write C by D, C over D is 3 by 2. That means we have to look for all such ordered pair which belong to this. So it's very easy, like C over D is what we have to get. So we can multiply here, say 2. For example, if I multiply 2, so what we'll get? 6 by 4. If I multiply 3, I'll get 9 by 6. If I multiply 4 here, then it's going to be 12 by 8. Multiplying 5, that is 15 by 10. Multiplying 6, 18 by 12. So we have to stop because the maximum, the highest number is 16 here. So we conclude 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And So counting this as well, we can say there are altogether 6 ordered pair present in the equivalence class of 3, 2, because we have to include this also. Now in question number 4, it says R be the relation of a set of n, that is natural number defined by n Rm, where n, the definition of the relation is n divides m. Then we have to figure out then the R is what? Reflexive, symmetric, transitive, equivalence and all. Let's say, if I say that here n divides m means what? N divides m. Now we know that all natural number is divisible, right? Every natural number, like say 7 divides 7. Now, similarly, if I say n divides m, it also implies that m divides, does it mean m divides n? Let's say, for example, if I say that 10 or say 2 divides 10, but 10 does not divides 2. That means 10 is divisible by 2, but 2 is not divisible by 10. So it is reflexive. We got it. It is reflexive. Reflexive is true. R is true. Symmetric is not true. Let's figure out the transitivity. Now, if I take M, say N, M, and R, so if N divides M and M divides R, so clearly N divides R as well. Like if I take 2, 5, and say 30, 2 divides 10 and 10 divides 30, it also implies that 2 divides 30. So it is transitive. So it's reflexive as well as transitive, but not symmetric. So therefore, we can say that D is the correct answer for this. Now we are on question number 5. In this question, there is a set given as 1, 2, 3, and the relation is defined with an ordered pair as 1, 1, 2, 2, 3, 3. Now, clearly, this is an identity relation, right? That where all the elements 1, 1, 2, 2, 3, T has their ordered pair present. So identity relations are always equivalent. So it is reflexive, as you can see, 1, 1, 2, 2, 3, 3 belongs to R, symmetric, and as well as transitive. Question number 6, similar to the previous question, we are given a set belonging which have elements 1, 2, 3, and R is a relation defined on the set A. And the definition of the relation is nothing but an ordered pair having some elements like 1, 1, 2, 2, 3, 3. We have to check whether it's a symmetric, reflexive, or transitive, or maybe all of them. Now, as we can see that we have the doublet of 1, 2, as well as 3. So we have 1, 1, 2, 2, 3, 3, and that's the condition for reflexivity. That's reflexive. Now, when we look into this, we are given 1, 2, and 2, 1 does not belongs to R. Because if you scan through, you see AB belongs to R, but BA does not belongs to R. So clearly, this is reflexive. Now, it is not symmetric. Now, coming to the transitivity. Okay, so we have an option reflexive but not symmetric, so we can say that this is correct. Now on question number 7, we have to figure out which of the following is not an equivalence relation on integers. It says ARB implies that A plus B is an integer. We know that even integer is what they are saying. You know that if I add 1 plus 1, we are getting 2, or maybe any odd integer, I'm getting an even integer. If I take two even integer, let's say if I take 6 plus 6, again, we are getting an even integer. So this is true, right? This is reflexive. It should be symmetric, as you know that if the sum is an even, by shuffling the order, that means if I say A plus B is an even integer, then B plus A should also be even. So this is symmetric and reflexive as well. Now we can figure out that same way. This should also be true. The difference of two even integer as well as an odd integer is always an even integer. Now, further, you can also figure out that if AB belongs to R here, implies that BA also belongs to R. Likewise, if you could take some examples like ABC belonging to an integer, and if AB is true, AB is true, BC is true, then AC is also true. But now in coming to this one, that is what not true here. It says that A or B such that A greater than B. So we can say that 7 is, if I take 7, 7, right? Checking for the reflexivity, 7 is not less than 7. It is equal to 7. So it is not reflexive, right? Even if you can take other examples, if I take 7 is less than 8, but that is AB belongs to R, but changing the order, we see that 8 is not less than 7. So it is not symmetric as well. So once it is not reflexive, we could have told in the beginning that it is not an equivalence relation, irrespective whether it's a transitive or symmetric or not. In question number 8, that's one of the textbook question. It says there is a set A has 3 elements, 1, 2, and 3 as the numbers. And then the number of relations, we have to find the number of relations containing 1, 2, and 1, 3. Now, which is reflexive, symmetric, but not transitive. Now, let's say if I write an ordered pair, now 1, 2, and 1, 3 has to be there, right? In order to make it reflexive, I must write 1, 1. That is doublet of all the elements, 1, 1, 2, 2, 3, 3. So that's reflexive. Now it also has to be symmetric. Since 1, 2 belongs to R, then 2, 1 also must belong to R. And 1, 3 belongs to R, then 3, 1 also belongs to R. Now what we have figured out that taking this as A and 1 as B, AB belongs to R and it was here far away. If BC belongs to R, 1, 2 also belongs to R, but AC, that is A being 3 and C being 2, 3, 2 does not belongs to R. So this is what the relation, right? That we can, hence we can say that there is only one such possible option, right? There is one such relations. So A is the correct answer in this case. In question number 9, it says L denotes the set of all straight lines in a plane. Let A, a relation, right? Let a relation R be defined L perpendicular to M, right? If for M that belongs to the set of lines, then R is what? Okay, right. So we know that let's say if I make a line, if I make another line over it, we'll say it's coinciding, right? It's not perpendicular. So that means considering a line L, the L1 is not perpendicular to L1, right? So this is not true. So clearly it is not reflexive. Now checking for the other, let's say if I make two lines, say this is L1, and let's say this W1 be L2. That means naming this as L1, this being L2. But we can see that L1 being perpendicular to L2 also implies that L1 perpendicular to L2. It means that L2 is also perpendicular to L1. That means AB belongs to R, then B also belongs to R. So clearly it is symmetric. Now coming to the transitivity, let's say if I make three lines, say one being perpendicular, black being perpendicular to the red and the blue being perpendicular to the red. And let's name this as L1, L2, and L3. Now L1 is perpendicular to L2 and L2 is, this is L2, is perpendicular to L3. But then L1 and L3 are not perpendicular. In fact, they are parallel using the corresponding angle property. So it is not transitive. So we'll say that symmetric is the correct answer for this. In question number 10, it says that, in question number 10, let f be a function from R to R. Well, clearly R is by default has to be real number if not mentioned. Defined by fx is equal to 1 by x for x belonging to R again. So it is very important to look into this question carefully that here x, that is the domain, is a real number, right? And we know that, let's say, if I write fx is equal to 1 by x, it's necessary to mention that this function is defined for all x other than 0. Once again, we know that fx is equal to 1 by x is defined for x not equal to 0 because any number divided by 0 is not defined. And it's not mentioned. Had it been x not equal to 0, then we would have found that whether it's a 1, 1. Then in that case, it is bijective, as you know that fx is equal to 1 by x. So fx1 is equal to fx2. So 1 by x1 is equal to 1 by x2. So it would have been x1 is equal to x2. So that's 1, 1. Similarly, it is an onto because if I take fx as y, therefore 1 over x is equal to y implies that y is equal to 1 over x is equal to 1 over y. X is equal to 1 over y, which is again defined for y is not equal to 0. Now, should have been bijective, but we need to see that here the domain is all real number and the function is not defined for x equal to 0. So in that case, we'll say that the function is not defined. For this particular question, the answer is this. Had it been x not equal to 0 mentioned, then it would have been bijective. In question number 11 is a function whose domain is from 2 to infinity and range is b here. And the definition of the function is this, that is fx is equal to x squared minus 4x plus 5 is a bijection, then b is equal to. That means this is both 1, 1 and onto. So we don't have to find whether it's a 1, 1 onto or not. That means we can figure out if the domain is this, then what is the range? So we can find out that placing the lowest value in this case, which is 2. So f2 is 2 square minus 4 times 2 plus 5. So this is 4 minus 8 plus 5. 4 plus 5 is 9. 9 minus 8 is 1. So that means 1, 2. And if I place an infinity over here, obviously we are going to get infinity only. So it's 1 to infinity should be the correct answer. In question number 13, that's a textbook question. We are given a function from R to R, that is domain being real number, and the range also should be a real number. The definition of the function is fx is equal to x squared. You have to figure out whether it's a 1, 1 onto. That means injective or surjective. Now, this is neither injective nor surjective, but I'm going to show it. Let's say that fx1 is equal to fx2, right? Such that these x1, x2 belongs to x1 comma x2 belongs to R. Replacing x1 is going to be x1 square plus x2 square. You know that in this case, x1 is not equal to x2. Instead, x1 is plus minus x2. So since x1 is not equal to x2, therefore, it is not 1, 1, right? Not 1, 1. So not injective is what you can say. Moreover, had this domain be natural number, right, n instead of r, if it would have been natural number, then we would have said, yes, it is 1, 1. Coming to the onto part, we take fx as y and replacing fx with y, we get x is equal to under root y. Now, let's say, for example, whenever we take an y as a negative natural number, negative integer or negative fractions or real numbers, like say, if I take minus 7, then x is under root minus 7, where x is not a, which is not a real number. Under root 7 is not a real number. So what we say, it is neither one word nor onto. So we say it's neither surjective, injective, or not surjective. So the D is the correct answer for this part. In question number 13, there is a function from R to R, and the definition of the function in the split format is given. That means for x less than 1, we'll take 3x, and for x greater than 1 but less than equal to 3, we should take this. For x greater than 3, it's going to be 2x. Now we have to find these values. So let's say if I do one by one, if I find f minus 1, clearly minus 1 is going to be among these three options, the splitting format given here, it is less than 1 only, right? So it is 3 times, we are going to use this function, that is fx as 3x, which is minus 3, f minus 1. So that is equal to minus 3. If I find f2, now look into 2. 2 is which is 2 belongs to this definition, which is greater than 1 and less than 3. So that means we are going to write 2 as f2 as 2 square, that is 4. Finally, it is f4. Clearly 4 is greater than 3. So this will be 2 times 4, that is 2 times 4 is 8. Now we have to get the sum of these three. So this is minus 3 plus 4 plus 8. So it's minus 3 plus 12 comes out to be 9. So A is the correct option in this case. In question number 14, we have to fill in the blanks. The question says that R be a relation defined on N, right? So here, the domain as well as range has to be natural numbers, such that ARB is 2A plus 3B is equal to 30, then R in the roster form. That means the set of ordered pair we have to write down in the roster form. Now, if I say that 2A plus 3B is equal to 30, let's say isolate either A or B. If I say isolate B, that's better. B is equal to 30 minus 3A over 2. Now, as you can see that we have to frame an ordered pair where both domain, that is A and B in this case, must be a natural number. Now, let's start placing A as 1. Now, when I place A as 1, clearly it is going to be 30 minus 3 is 27, which is not divisible by 2. So we have to keep in mind that we have to take a number A such that it is exactly divisible. We cannot take 2 as well, because 30, right? If I place A as 2, that comes out to be 6. 30 minus 6 is 24. Okay, let's say if I place A as 2, then this is 30 minus 6 over 2. 30 minus 6 is 24 by 2. That comes out to be 12. So we are obtaining B here. Well, A is this. Yeah, I can see that I made some mistake here. This is 2A, right? So let me redo this part. But I can see that if I isolate B here, so B is what? This is 30 times 30 minus 2A, and that divided by 3. Right. So now if I take A as 1, it's not divisible by 3. By placing A as 2 is again not divisible. With 3, it is divisible. Placing this as 3, this is 6, and 30 minus 6 is 24. That divided by 3 is 8. 24 divided by 3 is 8. Now if I take 4, again it's not divisible, because if you place 4, this is 30 minus 4, right, is 26, which is not divisible by 3, because we are looking for B as should also A and B must belongs to natural number, not just A. So we can place 6 here. So placing this as 6, 30 minus 6 is 20, 30 minus 6. Yeah, that's 24. And 30, if I place 2 into 6, that divided by 3, that is 12, and divided by 3, that is 30 minus 18 divided by 3, that is 6. So it's 6 comma 6. Now if I replace A with 9, this is 18. 30 minus 18, that is, we'll get B as 4. Further, if I replace A with 12, I'm getting 30 minus 12, 6 divided by 3, 2. So it's 12, 2. So you can say these are the ordered pair in the roster form. Now in question number 15, there is a function from real number to real number, the domain and range being real number, and the definition of function is fx is equal to x squared plus 1. We have to find out the pre-image, right? So pre-image is different from image. Like say, if I place x as 2, right? X as 2. So 2 squared plus 1. So is what? 4 plus 1, that is 5. So 5 is the image, right? So f2, the value of f2 is called the image. Then, but we have to obtain the pre-image, right? So how to obtain pre-image? Obtaining pre-image is same as obtaining y. So we are considering fx as y. Y is equal to x squared plus 1. So we can say x squared is equal to y minus 1, or we can say x is equal to plus minus under root y minus 1. So let's say if I replace y with 17, what we are getting x as. So this is 17 minus 1, x is equal to plus minus 16, and that is 4. Plus minus 16 is 4. Now we have to also get for minus 3, replacing the same, right? X squared being, or you can straight away write x is equal to plus minus under root y minus 1. So x is equal to plus minus, is y minus 1. Yeah, that's correct. Now replacing y with minus 3 is minus 3 minus 1. So x is equal to plus minus under root minus 4. As you know, this is not a real number. So we'll discard this and we'll say that the pre-image of 17 is plus minus 4 and the pre-image of minus 3 does not exist.